All right, 6.2 says use the law of sines to calculate the requested quantities from triangle ABC. Angle A is 45 degrees, angle B is 60 degrees, and side A is 10. Find side B. Well, remember, with the law of sines, that's where we use like sine of A over side A will equal sine of angle B over side B, which is also equal to sine of angle C over side C, right? And so you can set any of those two or three fractions equal to each other. So they gave us angle A and side A. So we know that sine of 45 degrees over 10 is going to equal sine of 60 degrees over, we're looking for side B. And so this is where we cross multiply and divide. So we know that side B is going to equal 10 times sine of 60. And then we divide by what was left there. So that would be the sine of 45 degrees. So 12.2, which is side B. And they didn't give us any units. Okay, on number 16, it says solve the side-side angle triangle. Indicate whether the given measurements result in no triangle, one triangle, or two triangles. Excuse me. Solve each resulting triangle. Round your answer to the nearest tenth. All right, so we're solving the triangle. So I'm going to go ahead and set it up. They told us angle A was 39 degrees, side A is 24, and side B is 15. All right, so when we have two sides in an angle, when we have the side-side angle triangle, then we're going to have to check for that second triangle. So remember, you started off just like you do with any others. What do you want to find first? Angle B. So using the law of sines, since we know angle A and side A, we can use that. We know that sine of angle A, the 39 degrees, over side A, which is 24, is going to equal sine of angle B over side B, which is 15. So again, we're going to cross multiply and divide. So we find that sine of angle B is equal to 15 sine of 39 degrees over 24. But remember, we're after angle B, so what do we have to do to find angle B? Yeah, we're going to take the inverse sine of that. And so what do we get for angle B? 23.2 degrees. But now remember, when we're doing the inverse sine, our angle can be in quadrants 1 or 2, correct? Well, I guess I shouldn't say the inverse sine, but when we're looking for sine of an angle and it's positive, because 15 sine of 39 over 24 is positive, it can be in quadrants 1 or 2. So this is obviously a quadrant 1 angle. But we need to see, is there a quadrant 2 angle that will work? Well, to find your quadrant 2 angle, remember quadrant 1 is the same as your reference angle, so that means this is 23.2 right here. So my quadrant 2 angle is going to equal 180 minus the 23.2, which is what number? Good. Now, that is a quadrant 2 angle. It could be part of the triangle, but we already know we have an angle that's 39 degrees. So when I add that 39 degrees to it, this has to be less than 180, so I have a third angle. But when I add them together, we get, is that too big or too, all right, yes, this is too big, which means we're not going to have that second angle on this one. So this one, it asked us to specify, to indicate if it was no triangle, one triangle, two triangle. So even though we're going to write just one triangle answers, let's go ahead and let's specify, just in case. So it's going to be a one triangle. And now we just need to finish solving it. We already know then that angle B is 23.2 degrees. What do you want to find next? Angle C. So again, that's 180 minus the other two angles added together. Which is? Good. So angle C is 117.8 degrees, and I'm sorry, I know this is messy. But now we got to find side C. How are we going to do that? Our law of sines, yeah. So sine of angle A, so 39, over side A, 24, is equal to sine of angle C, which we know is 117.8, over side C. So just cross multiply and divide. So side C is going to equal 24 times sine of 117.8 degrees over sine of 39 degrees. And we get approximately 33.7. Good. My angles all have degree symbols. My sides were not given with any units. So there's our triangle, and we specified that there was one. So 6.3 here starts with number 17, and it says find the unknown part in the triangle ABC to the nearest tenth. Use the law of cosines. So it told us, this one's a little weird because that's side B, guys. Even though he put a capital B, it's supposed to be a lowercase. So side B is 4, side C is 5, angle A is 60 degrees, and we're going to find side A. And I know that that was side B because it didn't have a degree symbol on the 4. Okay, so that's how I was able to figure it out. So, I'm going to go ahead and just write out what we've got. This helps me figure it out. If you don't need it, you don't have to. All right, and we're after side A. So this is what I need. So, and it tells me to use the law of cosines. So remember, the law of cosines has this formula. Right? So we can plug it in. A squared is equal to the 4 squared plus 5 squared minus 2 times 4 times 5 times cosine of 60 degrees. And then don't forget, we're looking for side A, so then you got to take the square root of all that. All right, and so we got 4.6 for side A, and it didn't have any units up there, so there's our solution.
We can't leave it a square root of
You probably could. You probably could. What was it, square root of 21? No, you can't, because it says to the nearest tenth. Okay, so that is exact, but the directions tell us for the nearest tenth, so. All right, so number 18. So solve each side-side angle triangle. Indicate whether the given measurement results in no triangle, one triangle, two triangles. Solve each resulting triangle, round to the nearest tenth. All right, so I'm going to move mine up here so we have room to work. All right, so we're solving the whole thing. So I'm going to go ahead and set it up. Go ahead and plug in what they gave me. Now remember, if we find that this has a second triangle, we would totally recopy everything we have written down now for the second triangle before we put in the angle that we're going to find. All right, so what would I do here? Yeah, even though this is listed in 6.3, I think it just got put in the wrong location because I know an angle on the side across from it, so that's going to be law of sines. I couldn't find any of the other stuff using the law of cosines, okay? So I can only use the law of cosines if I knew side C, if I knew angle C. So law of cosines doesn't work on this one. So using the law of sines, we know then that sine of 40 degrees over 23 equals, what are we finding? Angle B. So sine of angle B over 20. So cross multiply and divide. So sine of angle B equals 20 times sine of 40 degrees over 23. And then remember, we're after an angle, so we're going to do the inverse. And so when we do this, we find angle B is equal to 34 degrees, which, again, we know because we're using law of sines, we've got to look in quadrants 1 and 2, right? And so that would be my quadrant 1 angle. How do I find that quadrant 2 angle? Good. 180 minus 34, which is, and then to see if it will work, so that's my quadrant 2 angle that would give me that 20 sine of 40 degrees over 23 would give me. But to find if it's going to work, remember, add back in the angle that they gave us. This answer here has to be less than 180, is it? No. So that means there is no second triangle, but we do have one triangle. So I'm going to come over here and I'm going to list that we have one triangle. All right, so we found that we had one triangle, and that angle for angle B then is 34 degrees. And from there, we just got to find angle C and side C. So I'm sure you want to find angle C first, because that's what y'all have been doing all day. So 180 minus the other two added together, which is and then we can take and find side C, because we know that sine of 40 degrees over 23 will equal sine of 106 over side C, right? So cross multiply and divide. So C equals 23 sine of 106 over sine of 40. And so side C equals, good, 34.4. All right, so it says find the exact value of the area of the side angle side triangle, ABC. Now we had two formulas for sine, for area, okay? One of them involved an angle and one of them did not. This is the one that's going to have the angle, so we know that our formula is going to equal 1/2. It doesn't matter what the sides are labeled. In this case, it's B and C. So it's 1/2 B times C sine of the angle in between them. So since that's B and C, the angle would have to be angle A. All right, so we get K equals 1/2 of 7 times 5 times sine of 60 degrees. And so our area is equal to
4.6.
I thought I had 15.
Or 4.2.
That's what I had. The only problem I'm having right now when I look at this, and I'm going to put units squared so we don't forget it would be squared, is that it says to find the exact value, doesn't it? So that could have been the 35 over 2 sine of 60 degrees. And then leave it like that. Okay, because that's exact. Or you could have done 17.5 sine of 60 degrees. Okay, that's exact, but the other's rounded. Alright, I'm sorry. So yeah, we could find sine of 60 degrees. So this would be, what, 35 over 2 times, so square root of 3 over 2? So you'd have 35 square root of 3 over 4 is what it is exactly. So and then if we had to label it, it'd be whatever unit squared because it's area. Alright, so for number 19 there, it says determine whether the vectors A, B, and C, D are equivalent. So write them as position vectors. So if we want vector AB, remember the position vector is where you take x2 minus x1, comma, the y2 minus y1. So in this case, I would take 3 minus 1, comma, 4 minus 0, and find that this is 2, 4. I would do the same thing for vector CD. So 1 minus negative 1, comma, 6 minus 2, and find that it is 2, 4. And since they have the same position vector, then they are equivalent vectors.